we will start with the next unit. Okay. So far in unit 1 and 2 we have covered the statics part of our engineering mechanics. You know, I have already told in the introduction, the engineering mechanics can be classified as statics and dynamics. So what is the difference? In statics, we are dealing with no. What is mechanics first? Study of effect of forces. Study of effect of forces on bodies or particles or objects, whatever it is. But if the object is in rest, that is statics. If the object is in motion, it will be kinematics. Okay. So it is dealing with a body or object which is at rest, statics. Okay. And the dynamics, again we can classify as kinematics and kinetics. Kinematics and kinetics. So the difference is, in kinematics we will be bothered about the geometrical aspects of motion. How the motion is executed, what is the position, the geometrical aspects, the velocity, okay, like the position, velocity, how the geometry affects the motion. So these aspects only we consider, kinematics. Okay, generally we consider the 3 motion parameters. In kinematics we will be dealing with the position, displacement, velocity and acceleration. We won't be talking about the mass. Mass is not considered in kinematics, only the geometry, okay, the geometrical aspects of motion. Whereas if you consider mass, then we call it as kinetics. Mass is taken into account, we call it as kinetics. But in our engineering mechanics, since we are dealing with mass, okay, we have to consider the forces, we have to consider the masses. So the second part is generally on kinetics. Kinematics we will deal very less. Okay, only the kinetics is dealt with more in our unit 4 and unit 5. Unit 4, it starts with the basic principles of our dynamics. We will see about the Newton's law again. Okay, the Newton's second law is dealt in detail in unit 4. In unit 1, what are all the laws we have seen? Unit up to unit 3, in part 1, unit 3. What laws are dealt? First as well as third. Okay. What is the first law? You would have written in the test itself. So the ability of the body, the body will be remaining in the state of rest or motion unless otherwise acted upon by some external force, or it will be in equilibrium. The body will be in equilibrium unless otherwise there is a disturbance. Okay. So the equilibrium is sigma F or sigma M equals to 0, or the resultant forces and moment are 0 for equilibrium condition. So considering the equilibrium condition and also the other law, every action has opposite reaction. Okay, the other law, third law, we have solved problems of support reactions. Generally we have considered beams, okay, and many components which are having some support reactions. Okay, so wherever you cannot move, you are constrained to move, you are restricted to move, you will develop a reaction. You will show your resistance. So that resistance is called reaction. So that reaction may be of any kind according to the degrees of freedom you have. If you have 3 degrees of freedom, you will have 3 reactions. Generally there are 6 degrees of freedom your body can have in space. So you will have 6 reactions, 3 forces and 3 moments. 3 forces and 3 moments. You can translate X, Y and Z. You can rotate about X, Y and Z. Okay. So along X, Y, Z, you will have forces. About X, Y, Z, you will have moments. So either it may be supporting forces, reactive forces, or reactive moments. So these things are dealt in our unit first half. That is, we have seen for Newton's law of 1, Newton's second law, first law as well as second, first law as well as third law. The second law we are going to use intensively in our dynamics, because according to the second law, what is the second law? F equals to ma. So F is the force M mass A acceleration. So there is an acceleration. So there is a movement. So if the movement is there, motion is there, it comes under dynamics. Okay. So we will be dealing more on Newton's second law of motion in the second part. So first we see the syllabus. This is the syllabus. We start with Newton's second law. Then we will see about momentum, impulse, work energy equations. Okay. So second law, it gives you the dynamic equilibrium also. As I told earlier, equilibrium can be static or dynamic. F will be 0 under two conditions. There is no movement at all. Velocity is 0. That is the first condition. No velocity, no movement at all. It is at rest. So that condition is static equilibrium. What is the other condition? F will be 0 when velocity is constant. Okay, velocity is 0, F is 0. Because if velocity is 0, acceleration is 0. So F equals to ma, then A will become 0. That is first half, static equilibrium. In dynamic equilibrium, you will get equilibrium because if sigma F is 0, sigma F will become 0 when acceleration is 0. That means your velocity can be constant. Velocity can be 0 or velocity can be constant. If velocity is 0, static equilibrium. Velocity is constant, dynamic equilibrium. Okay, so this will be this can be applied to solve even dynamic problems similar to your equilibrium conditions. In our statics problem, we will be solving dynamics problem also, considering the same equilibrium, but dynamic equilibrium equations. Dynamic equilibrium equations we will be considering. Okay. And also about the work and energy. How will you define work? It's not definition. Work? Displacement?
Force required to move object to unit distance.
The displacement occurred by applying a force. Okay, will produce a will be the work done by the force. If a force is applied on an object and the object is displaced to some distance, then we will say work is done on the object. Okay. So the force applied to make a displacement will produce a work. Okay, actually now we will see work, also we will see virtual work. Virtual work means there is a real work and also there is a virtual work. The concept of virtual work will be used in many of the dynamic problems to solve them. Okay, like your equilibrium equation. Equilibrium equations are used to solve the unknowns, is it not? If you have any unknown in the equation, in the forces acting on a system, we can solve them by considering at equilibrium, considering the system at equilibrium. So that is one method of solving the unknown in system of forces. There is another method where we consider virtual work. Virtual work. Virtual means unreal. Virtuality, virtuality you say. So virtual means unreal, or you can say imaginary work. So the virtual work concept can be used as an alternative method for your equilibrium conditions, and you can solve for the unknown forces also. That is, so we will start with work. Also we will see the virtual work. So what is virtual work? How this virtual work principle can be applied to solve the equilibrium, solve the system of forces. And also there is an impulse and momentum. What is momentum? We will see. What is impulse? Force in relation to some time. Force is applied with respect to some time. Okay, in few seconds, how much force is applied. Okay, so that force with respect to area, what is that we call? We say pressure. Other name? Stress. Okay, so the intensity of force with respect to area, we call it as stress. Similarly, force with respect to time, we call it as impulse. The intensity of force is stress, that is with respect to area. Similarly, the force with respect to time, in relation to time, we call it as impulse. Okay. Similarly, movement with respect to time is velocity, acceleration. So these are all, if it is repeated, we will get another phenomena called vibration. Vibration. You will see the second law. our unit 4 is dealing with vibration. Most of our mechanical components, they are subjected to vibrations. Okay, vibrations are generally known as signatures of machineries. Like signature for every one of us is unique. Okay, like same way, the machine, if it produces some vibration due to particular fault will be unique. Say you have a defect in the bearing, defective bearing, worn-out bearing is there. So because of that worn-out bearing, you will have some vibration. That vibration will be different. If there is a misalignment in the shaft, due to misalignment problem in the shaft, you will have some particular kind of vibration. That vibration will be different. So likewise, if you have experience, you can detect this vibration is because of what reason. You can diagnose the system by looking at its vibration. So that is why we call it as a signature of the machine. Signature, vibration is a signature of a particular machine part, machine problem. Okay, we can. So the vibration, is it advantage or disadvantage? Where it is advantage, where it is disadvantage? Do you have to avoid vibration or do you have to introduce vibration? Avoid vibration, okay. So Engg, where should we avoid vibration? So in our automobiles, we have to avoid vibration. So for that, what is the component we are using? Suspension. Vibration on the seat. So suspension system, or we call them as shock absorbers. Your shock absorbers are vibration resisting components, vibration resistors, or we call them technically as dampers. They dampen the vibration, they absorb the vibration. That is why we call them as shock absorbers. Okay. Then, in some cases, we have to introduce vibration. Speakers, no.
Drilling machine, sir.
Drilling machine. Coffee shaker. Another. Washing machine. There is rotation only, vibration. System vibrate due to its head absorb vibration. Side effect. Okay. Like as you told, the coffee shaker, we have sieves, mechanical sieves. We can filter, sort out. Sorting machine, we call sorting machine. We can sort out different size of components. You will see it in material handling. You have to say, for example, you have a FMS, flexible manufacturing system, okay, in which the components will be passed to different machine centers. There is a drilling machine center, there is a milling machine center, there is a surface grinding machine center. Like that, you may have different machine centers located in the shop floor. You have to pass a machine components, different machine components to each machine center in a particular orientation. For example, surface is to be grind, and at the perpendicular to that surface, a drill hole is to be formed. Okay, so in that case, you have to tilt your workpiece to 90 degrees. Orientation. We have to orient your workpiece to 90 degrees. So that orientation can be done by using that sorting machine. So the sorting machine will be like, it will be vibrating, and there will be a hole which allows only a particular dimension. The horizontal dimension, there is a length and breadth. Breadth is smaller, length is larger, that we know. So it cannot insert through the length, it can insert only through the breadth. Like that, it will vibrate so that the workpiece will go vertically downward and get seated in the machine, and it will be drilled. So like that, I'm telling just an example. So in a similar way, you can sort out components according to our requirement by using a mechanical vibrating sieve. Mechanical vibrating. So we introduce vibration purposely in order to do some work, some useful work. Okay, so sometimes vibration is necessary, but most of the time vibration is to be avoided. So vibrations can be again classified into three kinds. One, according to the direction of application of force. So if you apply the force parallel to the axis of the component, we call it as longitudinal vibration. Suppose if you apply perpendicular, transverse. If you apply around the axis, then torsional vibration. So there are different kinds of vibration. Mostly shafts are subjected to torsional vibration. Springs may be longitudinal vibration. Beams, etc., they will be subjected to transverse vibrations. Okay. So how to, in our second part, we will see how to find out the vibration. A vibration, the what do you call it, the damaging parameter of the vibration, we call it as natural frequency. The parameters of vibrations are frequency and amplitude, two important parameters of vibration. Like motion, what are the parameters of motion? Displacement, velocity and acceleration. Three main parameters. Displacement, velocity and acceleration. Tippuraj, Munadu. Okay. Similarly, vibration has got two important parameters, frequency and amplitude. Okay. How much frequently it repeats its motion. Repetition is called vibration. It moves up and down, to and fro, or rotate, clockwise, anti-clockwise. So these are all vibrations. Okay, clock, it vibrates. The spring inside the clock. Okay, it swells and it winds and unwinds like that. It is subjected to some torsional vibrations, spiral vibrations, helical vibrations. There are different kinds of vibrations generally. But the vibration, how much frequently it occurs, that is important. Frequency of vibration. Then how much how much distance it displaces. The distance of displacement, that is called amplitude. So the frequency and amplitude are two important parameters. Okay, so you have to find out, and frequency, a particular frequency at which your amplitude will be maximum. What is the condition? Resonance. And the frequency is called natural frequency. The frequency at which the resonance condition is reached. Resonance condition is reached. That condition is called, that frequency is called natural frequency. So these are all the things we will be seeing only for single degree freedom systems. What do you mean by single degree freedom system? You need only one parameter to define its position. The system is like that. It can be displaced in theta angle or in x direction. Like that, it displaces only in one direction. So such a kind of systems, we call them as single degree freedom system. If they displace in such a way, you need two parameters, then we say 2 degree freedom system. Multiple parameters, multiple degree freedom system. Okay. So our syllabus is, the scope of the syllabus is only single degree freedom. So first we start with Newton's second law of motion, and we will see the other topics also. So as I told earlier, dynamics is dealing with the study of effect of forces on the moving objects. It can be kinematics or kinetics. Kinematics, geometrical aspect. Kinetics, the mass is considered. So Newton's first and third law of motion were used extensively in our first half, statics. Okay. Now we are going to see about the second law. The two laws are also used in dynamics. They are sufficient for the study of motion, and there is no acceleration. If the acceleration is not considered, then the first two laws is enough. First and third laws are enough. But if the acceleration is considered, the Newton's second law of motion is important. So acceleration occurs when there is a change in the magnitude of velocity or direction of the velocity. Open the window. So what is Newton's second law of motion? If the resultant force acting on the particle is not zero, okay, so the particle will have an acceleration in the direction of application of force, and its magnitude will be proportional to the force. So the acceleration is proportional to the magnitude of the resultant force, and it will be occurring in the direction of the force. So therefore F force is proportional to the acceleration. Okay, F and A are proportional, or we can write F by A. F by A is constant. This constant is called mass, or we can write it as F equals to ma. F equals to ma. According to the Newton's second law of motion, the force applied will be equal to mass of the particle times its acceleration. So the acceleration will be along the direction of application of force. If there is a particle of mass m, the force applied will be along the direction of application of force. So this laser, as it accelerates, there is a frictional force existing between the tires and the road. Okay, so it will be acting along the direction of motion. Generally, the motion will be resisted by the friction. Motion will be resisted by the friction. The friction will be acting opposite to the motion. Okay, but as it accelerates, the motion along the direction of motion, the frictional force will be acting and it will be accelerating faster due to the friction. So suppose if there are many forces, if the particle is having many forces, then we can apply sigma F, sum of all the forces, so the resultant will be equals to ma. Okay, mass times acceleration of the sum of the all forces acting on the particle. Okay. And A is the acceleration of the particle. So this equation is called equation of motion of the particle when it is subjected with many forces. Equation of motion. Okay. So you can derive equation of motion in many cases. If it is subjected to impulse, if it is subjected to momentum, if it is subjected to vibration, you may have to derive equation of motion for every object when it is subjected to particular kind of force. Okay. The force may lead to impulse, force may lead to acceleration, force may lead to vibration also. Repeated force may lead to vibration. So the basic equation of motion is F equals to ma. There may be some addition or deletion in this equation, but the basic equation is F equals to ma. Sigma F, summation of all the forces acting on the system, equals to ma. So this equation is called equation of motion. So suppose if we consider, as I was telling you, static and dynamic equilibrium, if we consider dynamic equilibrium, this equation I write it as sigma F minus ma equals to 0. Okay, this minus ma is the internal force existing internally, or we say inertial vector. This minus ma is the force acting on the particle. This is called inertial vector. Okay, sigma F minus ma. We consider all the external forces as well as internal forces acting on the system equals to 0 under dynamic equilibrium. So if you write this equation like this, sigma F minus ma equals to 0, this is similar to our equilibrium equation in our statics. Okay, sigma F equals to 0. Here only difference is we consider the inertial force. We will see about inertial force later in kinematics in detail, kinematics of machinery in detail about the inertia forces. How to find out the inertia force, how it will be acting on mechanisms, how we can analyze the mechanism considering inertia force. So all this kinematics dealing will be done in our next semester, fourth semester. So this inertia vector, this is called inertia vector minus ma. That minus ma is called inertia vector. Okay, the minus ma is actually the internal force. So you have force F1, F2. There are many forces. Each will have their resultant force. Then minus ma. So sigma F, all the external forces plus this internal force minus ma equals to 0. So this will bring your system to dynamic equilibrium. Okay. So we convert a dynamic system similar to a static system by using this equation and we can solve it. So the dynamic can be modeled as static system and we can solve it. இங்க ஏதோ அடுத்த லெக்சர் நடக்குதுன்னு நினைக்கிறேன். முன்னாடி லெக்சர் ஏதோ நடக்குது. Now we'll see about momentum. Okay, I was telling about momentum and impulse. First we will see about momentum. In the equation sigma F equals to ma. Okay, we replace acceleration by dv by dt. Acceleration is rate of change of velocity. Okay, so we replace this a as dv by dt. Mass is constant, and this can be brought inside. We put it as d over dt times m into b. That mv inside the bracket is called momentum, linear momentum of the particle or momentum of the particle. Simply say it as momentum of the particle. So this is the track. Okay, the motion track of the particle. Force applied is like this. Momentum will be acting along the direction parallel to the force. Okay, so this is the mass or the particle. It is exhibiting a motion along the track shown. If the force is applied like this, the momentum will be along the direction of application of force. So this mv, mass into velocity, that is called as momentum. Okay, or linear momentum. If the same direction as the velocity of the force and equal to mass times velocity. This is called linear momentum of the particle. So this expresses, suppose if we consider sigma f equal to 0, sigma f equal to 0, then your momentum will also be equal to 0. The resultant force acting on the particle is equal to rate of change of linear momentum of the particle. And it can be equal to 0 if rate of change of linear momentum is 0. Okay. Yeah? Previous slide. Momentum is m times v. That term is called momentum. Okay. And force is actually rate of change of linear momentum. Mass times rate of change of linear momentum is called force. Or not mass, rate of change of linear momentum is called force. Mass is already brought inside. After coming in addition to velocity, we get momentum. Okay, mass times velocity is momentum. So rate of change of linear momentum is otherwise known as force. Mass into acceleration is force. Similarly, rate of change of linear momentum is also can be called. So in linear momentum, we consider the velocity. Okay. So if the resultant force is 0, your linear momentum will be constant. So this is called principle of conservation of momentum. The resultant force acting on the particle is 0. Linear momentum of the particle remains constant in both magnitude and direction. Now we will do one problem on Newton's second law. This is the problem it takes up. It is pulling 2 carts. Okay. So the weight of the truck is given, weight of the cart is given. You are asked to find out the horizontal force acting on the truck. So if you apply sigma f equal to 0, you can go it to resolve similar to our statics problem. Sigma F can be sigma Fx equals 0, sigma Fy equals 0, sigma Fz equals 0. Okay, the same statics concept can be applied here to solve the unknowns. Okay, so sigma Fx, here you are asked to find out the horizontal force acting on the truck. Horizontal force acting between the coupling between the truck and car B, you have to find out at the instant. Okay, the force is given in terms of time, 160 T. The driving force developed at the wheels of the truck is given as 160 T. Okay. The load on each vehicle is given. The main truck 3600 Newton and other cart A, cart B, the forces are given. So first we have to find out an expression for acceleration. Using F equals to ma concept, we have to find out the expression for acceleration. You apply it under equilibrium condition and find out the horizontal force. The two steps are there. The time period T is already given 2 seconds. Okay, so it's from rest. After reaching 2 seconds, what is the force developed? So that is the problem. Okay. The truck starts from rest and it reaches some distance after 2 seconds. So at 2 seconds, what is the force developed? Horizontal direction, in the horizontal direction. So first we have to find out using F equals to ma the acceleration. We find out acceleration in terms of time t. So for that we have to consider the whole system as a single one. You have 3 cars, 3 vehicles, but we consider everything as a single system. Okay. 3600 vertically. Mass. Mass. 3600 divided by 9.81. W by G. W by G. 3600 is W. Okay. Each vehicle has got so much weight. It is given 3600 is the weight of the truck. 2200 and 1300 are weights of the car A and B respectively. So you have to find out mass of each one, add up all the masses, multiply by A. Okay, so that will give you, that is A not T. So multiply by A will give you the force. F equals to ma. All are supporting, all are reactions developed at the road. Okay. Friction will be acting horizontally. Okay. So the normal reactions developed at the road, okay, developed for the load of the vehicle at the road will be Na, Nb, Nc, normal reactions. So whenever you have a weight acting on the space, it's different. If it is in contact with some object, there will be some reaction. Action reaction. between the truck and car A, force acting on the coupling between the truck and car A, you have to find out. Okay. Now you have to draw the free-body diagram for the truck, then we have to go for finding out the force. So first, by using the Newton's law, we have found acceleration, the expression for acceleration. Okay. 160t is given. Force equals to 160t.
Okay, sir. Right side.
M mass times A, not T. So now we draw equilibrium diagram for truck only. So the load of the truck is there, then the frictional acceleration force Fa, then you have some load which you have to track it, tracking load coming from the other car A and car B, that is considered as T. Tracking load is considered as T. Like tension in the cable, we have a tracking load. The truck is to pull. Okay, the tracking load is considered as C. So the FA is acting in the forward direction, that is 160T, 160 small t. Okay, and the capital T is the tracking load, that is opposite to the FA. So 160T minus capital T. That is why 160 times 2 seconds. It is 160 times 2 minus T. So this is MA only. MA. So A already found as 0.22 T. Okay, we have substituted T as 2 seconds. We got the answer.